Have you ever wondered why Mercury, the smallest planet in our solar system, has such a large iron core? Indeed, it's a question that has puzzled astronomers and space enthusiasts alike for years. Let's dive right into this mystery. Mercury, the innermost planet in our solar system, is a world of extremes. Its close proximity to the Sun means it experiences scorching temperatures during the day, yet its lack of atmosphere results in freezing nights. But perhaps the most intriguing aspect of Mercury is its size. It's the tiniest planet in our solar system, yet it holds a disproportionately large iron core. This core, which makes up a whopping 60% of the planet's total mass, is a marvel. To put it into perspective, Earth's core only accounts for about a third of its mass. So what could possibly account for Mercury's unusually large iron heart? Astronomers have proposed several theories. One suggests that Mercury was once a much larger planet, but a catastrophic collision with another celestial body stripped away most of its outer layers, leaving behind the heavy iron core. Another theory proposes that Mercury's close proximity to the Sun caused the lighter elements to evaporate, again leaving behind the iron core. However, the most widely accepted theory is known as the hit-and-run scenario. This suggests that in the early stages of the solar system, Mercury was involved in a high-speed collision with another planet-sized body. The impact was enough to strip away much of Mercury's mantle and crust, but left the core intact. But as with all things in science, these theories are not definitive. There's still much we don't know about this enigmatic planet. New missions and technological advancements may yet shed light on Mercury's mysteries. So, the next time you look up at the night sky and marvel at the wonders of our solar system, spare a thought for Mercury. This peculiar planet, sitting closest to the Sun, holds many secrets yet to be discovered. The story of Mercury's discovery is as fascinating as the planet itself. Long before the invention of telescopes, ancient Greeks were already in awe of this shimmering celestial body. They named it Mercury, after their swift-footed messenger god, a fitting tribute to the fastest planet in our solar system. Fast forward to the 17th century, and the invention of the telescope gave us a closer look at Mercury. This tiny, fast-moving planet, once just a speck of light to the naked eye, now revealed its craters and rough surface to curious observers. But it wasn't until the 20th century that we truly began to unravel Mercury's mysteries. Space probes like NASA's Mariner 10 and Messenger offer detailed studies of this enigmatic planet. These missions unveiled Mercury's complex geological history, its magnetic field, and its incredibly thin atmosphere. From ancient stargazers to modern astronomers, Mercury has always intrigued us. Mercury's rugged terrain tells a tale of a planet with a turbulent past. This tiny celestial body, the smallest in our solar system, is a world of extremes and paradoxes. Its landscape is a stark testament to the violent history it has endured. Imagine a world where the ground beneath you is scarred and pockmarked, a testament to the countless meteorites that have struck its surface over billions of years. This is Mercury's terrain, a place where craters upon craters layer on top of each other, forming an intricate pattern of scars that map out the planet's tumultuous past. The lack of a substantial atmosphere on Mercury means that its surface is exposed directly to the harshness of space. Without an atmosphere to protect it from meteorite impacts, every collision leaves a permanent mark. This results in a landscape that is, in essence, a frozen snapshot of time, preserving the history of the solar system in its cratered surface. But amidst this barren, cratered landscape, there are surprises. In the permanently shadowed regions of Mercury's craters, scientists have discovered something extraordinary. Water ice. Yes, you heard it right. Water ice exists on the planet closest to the Sun. These craters are never touched by sunlight, and with temperatures that can drop to -275 degrees Fahrenheit, they serve as cold traps, preserving the ice from evaporating. The presence of water ice on Mercury is a tantalizing hint at the possibility of life, however remote. It's a stark contrast to the extreme conditions that characterize the rest of the planet, a world of scorching heat and freezing cold, of unending days and long dark nights. Mercury's landscape is a world of contradictions and mysteries. It's a place where the harshness of space is laid bare, where the scars of the past are etched into the surface for all to see. The landscape of Mercury, a testament to its dramatic geological history, continues to perplex scientists. Probing Mercury has been a monumental task, but our relentless pursuit of knowledge has led to some groundbreaking discoveries. In the 20th century, we embarked on a mission to investigate this enigmatic planet with the Mariner 10 spacecraft. This was mankind's first encounter with Mercury at close quarters. Mariner 10, despite its technological limitations, managed to capture images of almost half of Mercury's surface, unveiling a world scarred by meteor impacts and etched with vast, snaking cliff systems known as scarps. In addition, Mariner 10 discovered Mercury's magnetic field, a feature that was, at the time, thought to be unique to Earth. This discovery challenged our understanding of planetary science, compelling us to reconsider what we thought we knew about tiny rocky planets like Mercury. Fast forward to the 21st century, we launched the Messenger mission, a more advanced probe designed to delve deeper into Mercury's secrets. Messenger orbited Mercury for 4 years, capturing detailed images and collecting invaluable data. One of Messenger's most startling discoveries was evidence of volcanic activity, suggesting that Mercury was, or perhaps still is, geologically active. Messenger also detected a thin exosphere around Mercury, an ultra-thin atmosphere composed mostly of sodium, potassium, and oxygen. These are elements we wouldn't typically associate with the hostile environment of Mercury. The presence of an exosphere points to complex processes occurring on and beneath Mercury's surface, such as solar radiation stripping away the planet's outer layers and the possible outgassing from the planet's interior. These missions have fundamentally reshaped our understanding of Mercury, yet we are far from having a complete picture. Each discovery seems to lead to more questions, each answer to a new mystery. That is the beauty of space exploration. The quest for knowledge is never ending. Our probes have only begun to scratch the surface of Mercury's many mysteries. The exploration of Mercury is far from over. In fact, it's just getting started. The latest findings from the Bepi-Colombo mission, a joint venture of the European and Japanese space agencies, have shed new light on the mysteries of Mercury. For starters, Bepi-Colombo's high-resolution images have given us a fresh perspective on the surface of the planet, revealing an array of craters and geological formations that are as captivating as they are puzzling. But it's not just about the surface. Bepi-Colombo has also probed beneath Mercury's crust, detecting signs of a molten core. This finding is revolutionary, as it might explain why Mercury has a magnetic field, a feature that's quite unusual for a planet of its size. And if Mercury does have a molten core, it could mean that the planet is tectonically active, something which researchers are eager to investigate further. So, what's next for the exploration of Mercury? Well, the Bepi-Colombo mission is far from done. It's set to continue its observations until the late 2020s, and its data will likely keep scientists busy for years to come. But there are also other missions on the horizon. One such mission is NASA's Messenger 2.0, a proposed venture that aims to follow up on the original Messenger mission, which ended in 2015. Messenger 2.0 would delve deeper into the questions that Bepi-Colombo is currently exploring, like the geology of Mercury's surface and the nature of its core. These future explorations are driven by key questions that researchers hope to answer. Questions like, how did Mercury form and evolve? Why does it have a magnetic field? What can Mercury tell us about the early solar system? As we continue to explore Mercury, we look forward to uncovering more of its secrets and furthering our understanding of this enigmatic planet. The journey may be long and filled with challenges, but the rewards, the potential for new discoveries and insights make it all worthwhile. Mercury, a tiny planet with a big personality, has captivated us throughout history. As the smallest and innermost planet in our solar system, it's a world of extremes, with an enormous iron core that makes up nearly 3/4 of its mass. It's a place of mystery, first spotted by ancient astronomers, yet remaining largely unexplored until the 21st century. Its landscape is a testament to the brutal forces of space, weathered by meteorite impacts and scarred by immense cliffs. Our understanding of this enigmatic world has been shaped by daring missions, like NASA's Messenger and Bepi Colombo, a joint mission by ESA and JAXA. Each mission has peeled back a layer of Mercury's secrets, revealing a planet far more complex and intriguing than we ever imagined. And as we look to the future, the exploration of Mercury promises to unlock even more cosmic mysteries. As we continue to explore the cosmos, Mercury remains a fascinating and vital piece of the cosmic puzzle.